In the brutal combat theaters of World War II, survival often depended entirely on the reliability of standard-issue equipment. However, logistical failures and rushed engineering forced countless frontline troops to carry critically flawed firearms that endangered their own lives. Today, we catalog the specific frontline weapons that soldiers universally despised using in combat, detailing the exact mechanical failures that caused them to fail when they were needed most. First on our list, we have the M50 Rising submachine gun, an American firearm initially issued to Marines in the Pacific Theater due to severe shortages of the standard heavy submachine guns. This weapon was originally manufactured to strict civilian police specifications, resulting in tightly fitted internal mechanisms that were entirely unsuited for gritty frontline environments. The Rising suffered from extreme unreliability, constantly jamming as soon as the receiver was exposed to the mud, sand, and salt water of island combat. Furthermore, the charging handle was awkwardly positioned inside a recess beneath the foreign, making it exceptionally difficult for a soldier to quickly clear malfunction while under heavy enemy fire. The situation became so dire that officers famously ordered their units to throw these submachine guns into rivers and scrounge for bolt-action rifles instead. Ultimately, this firearm serves as a primary example of why delicate civilian engineering fails completely during the harsh realities of World War II combat. Next, we have the Type 94 Namboo pistol, a compact Japanese sidearm that is widely regarded by military historians as one of the most dangerous and poorly designed service pistols ever adopted. Issued primarily to tank operators and flight crews who required a smaller weapon, this firearm featured a catastrophic engineering flaw in the form of an exposed sear bar positioned on the left side of the receiver. If a soldier merely bumped this external bar, pressed it against the tight confines of a vehicle canopy, or even holstered the weapon improperly, the pistol would instantly fire a chambered round without the trigger ever being touched. This critical defect caused numerous lethal accidental discharges, making the weapon a severe hazard to the very operator carrying it. Additionally, the weapon fired an underpowered 8mm cartridge and required a deeply complicated disassembly process that frustrated users in the field. Consequently, soldiers heavily distrusted this sidearm, treating it as an active liability rather than a tool for personal defense. Let us continue with the Brada Modello 30 light machine gun, the standard squad support weapon issued to the Italian army throughout the conflict. This complex firearm operated on a delayed blowback system that lacked the necessary primary extraction power to smoothly eject spent cartridge casings. To prevent the brass cases from tearing apart inside the chamber, engineers installed an internal oil pump designed to lubricate every single round before it was fired. Unfortunately, in the arid desert battlefields of North Africa, this constant stream of oil immediately attracted blowing sand and dust, creating a thick, grinding paste that caused constant jamming. Furthermore, the weapon relied on fragile 20-round brass stripper clips, which drastically reduced the overall volume of fire a squad could project during an engagement. Soldiers completely despised this over-engineered weapon because the exhaustive maintenance requirements made it almost entirely useless in sandy operational environments. Moving forward, we examine the projector infantry anti-tank, commonly known as the Pyet, which served as the primary portable anti-armor weapon for British infantrymen. Unlike rocket-propelled launchers, this system utilized a heavy spigot mortar design, which offered the tactical advantage of having no dangerous backblast. However, soldiers universally hated this device because it weighed a grueling 32 pounds unloaded, placing an immense physical burden on the operator during long marches. To prime the weapon, a soldier had to stand up while under enemy fire, place their feet squarely on the shoulder pad, and heave upward with massive physical force to compress an incredibly stiff mainspring. If the brutal recoil of firing a projectile failed to automatically recaught the mechanism, the exhausted infantryman was forced to repeat this terrifying manual process in the middle of a frantic firefight. The combination of excessive weight and a highly dangerous, physically punishing reloading sequence made it one of the most dreaded weapons to operate in the field. Next on the catalog, we have the Gewehr 41, an early semi-automatic rifle developed for the German army to compete with advanced Allied firepower. The design of this rifle was severely compromised from the very beginning because military bureaucrats explicitly forbade engineers from drilling a standard gas port directly into the barrel. To bypass this restriction, the manufacturers utilized a complicated gas trap system located at the extreme end of the muzzle, making the entire rifle awkwardly front-heavy and terribly unbalanced. During prolonged engagements, this delicate muzzle trap rapidly accumulated thick carbon fouling from the highly corrosive ammunition used during World War II. If the frontline soldier failed to meticulously clean this specific trap every single day, the internal mechanisms would completely seize up, turning the advanced rifle into a heavy and clumsy manually operated weapon. The troops thoroughly despised this initial model, until it was finally replaced by vastly improved designs later in the conflict. Now we look at the Stengun, specifically the early production marks, which provided crucial, desperately needed firepower for British forces and resistance groups. While historians rightfully praise its cheap stamped metal construction for saving the British war effort, the soldiers forced to carry it daily had a completely different perspective. Troops deeply hated the dangerously crude open bolt design, which was notorious for causing accidental discharges if the weapon was simply dropped onto a hard surface. Moreover, the firearm utilized a highly flawed double-stack, single-feed magazine system that was incredibly prone to catastrophic feed failures when exposed to battlefield debris. Soldiers often had to consciously avoid holding the weapon by its side-mounted magazine, because any slight pressure would misalign the feeding angle and cause an immediate jam during close-quarters combat. Ultimately, it was an uncomfortable, poorly balanced piece of stamped steel that troops only trusted when absolutely no other options were available. Continuing down the list, we have the Boy's anti-tank rifle, a massive 5-foot-long weapon originally designed to halt early interwar armor. By the time World War II heavily escalated, advancements in thick enemy tank plating rendered this heavy rifle completely obsolete against mainstream armored vehicles. The soldiers forced to carry this 35-pound behemoth across the battlefield hated it because the physical effort required simply did not match its rapidly diminishing tactical value. When fired, the massive 55 caliber armor-piercing round generated a brutal, punishing recoil that caused severe shoulder bruising and neck injuries to the operator. Even with a heavily padded shoulder piece and a muzzle brake, the sheer concussive shock of discharging the weapon made troops absolutely dread pulling the trigger. It was eventually phased out of frontline anti-armor rules, leaving a legacy as an agonizingly painful and excessively heavy burden for the infantry. Next in our analysis, we have the Type 11 Might machine gun, an early Japanese squad automatic weapon that featured a highly unusual and deeply flawed ammunition delivery system. Instead of using standard detachable box magazines, this machine gun utilized an open hopper feed tray positioned on the left side of the receiver. Soldiers were required to constantly drop standard 5-round infantry rifle stripper clips directly into this open hopper while the gun was actively firing. Unfortunately, this exposed, wide-open feeding mechanism acted as a funnel, allowing dirt, mud, and battlefield debris to fall directly into the delicate internal action of the firearm. Because of this fatal design flaw, the weapon was incredibly complex to maintain and suffered from constant, catastrophic jamming in the harsh jungle environments of the Pacific Theater. Infantry units despised relying on this system because the constant need for meticulous cleaning directly compromised their ability to sustain suppressive fire against the enemy. Finally, we conclude with the Krumn, a bizarre curved barrel attachment designed for the German assault rifle to allow soldiers to shoot safely around corners or from inside armored vehicles. While the concept sounded incredibly innovative to high-ranking officers, the frontline troops who were actually ordered to use it viewed it as a dangerously flawed and over-engineered gimmick. The extreme internal friction caused by the curved steel barrel meant that the heavy rifle bullets frequently shattered into harmless shrapnel while still traveling mid-air, rendering the weapon completely useless for hitting targets at any practical distance. Furthermore, the immense pressure and heat generated by redirecting the bullet path caused the metal attachment to rapidly warp, crack, and destroy itself after firing just a few hundred rounds. The attachment also drastically altered the weapon's center of gravity, making the already heavy firearm incredibly awkward and entirely unbalanced for a marching infantryman. In the end, soldiers hated carrying this fragile, short-lived attachment, preferring standard combat tactics over relying on experimental equipment that violently tore itself apart during battle.